Hi, now let us look at this question here. Now we have a particle which is in equilibrium. So this particle here is in equilibrium, meaning that it does not move, it is in that position. So to be in equilibrium, that means forces in one direction must balance the forces in the other direction. So here, forces which would pull this particle to come down must be called the forces which are holding it. These forces which act upwards. So we can see that we have four forces acting on it. So in problems involving inclined plane, we always have to resolve along the plane. So let us see if this is our plane and this is our particle here. So we do have a 5 Newton acting downward. We also have this force acting down the plane. Now which we also see that is this force here at an angle of alpha, and there is a force which is perpendicular to the plane. So what we normally do is to resolve. So this angle here is 30 degrees. So if this angle is 30, this is 60, meaning that the 5 newtons when resolved, because here are such problems, we have to resolve along the plane and the perpendicular to the plane. So along the perpendicular to the plane and along the plane, let us see the 5 Newton first. This angle here is going to be 30. Reason that this is 30 degrees, this angle here will be 60, but remember this is a perpendicular. So I have this side and I'll have this side here. So resolving this 5 Newton, I have 5 cos 30 degrees, and I have this one which is opposite. So 5 sin 30 degrees. So this is the 5 newtons which is in this direction. So you need to resolve it perpendicular to the plane. So you have to move from here, take this direction, then move down the plane. So perpendicular to the plane, the 5 Newton is acting in this direction, and along the plane, the 5 Newton is acting in this direction. So if this angle is 30, this side is sine and this side is cos. So up we have these 2 newtons. Now let us see this force P. This force P is moving at along this direction at an angle of alpha along the plane. So what we shall do is also to resolve it along and perpendicular to the plane. So P, you take this direction. So this side is adjacent to the angle, so it is P cos alpha. Then you move up the plane and then perpendicular to the plane but in that direction. So this side is going to be P sin alpha. So don't forget that this angle here, this force is also here 80 newtons. So I'm going to now equate the forces in opposite directions. We are going to see forces pulling the particle up and the forces pulling the particle down. So down we have 80 Newton, we also have the 5 sin 30. Then up we have P cos only. So let us see. Along the plane we have 8 plus 5 sin 30 equal to the only force which is making this particle to move up the plane is P cos alpha. So let us see now vertically along the plane, or perpendicularly along the plane. So perpendicular along the plane, we have these two up and this P sine balanced by this 5 cos. So 5 cos 30 degrees will be equal to 2 plus P sine alpha. So those are the two equations which you need to solve simultaneously. There are two unknowns and two equations. So you can solve these two equations simultaneously. We get P and we get alpha. So what I'm going to do is to write P sine alpha equal to, now this is 5 cos 30 degrees minus 2. Then also P cos alpha from equation 1 is equal to 8 plus 5 sine 30 degrees. So to find alpha, I'm going to divide the two equations because I have a sine and a cos. When I divide, P disappear and the sine over cos gives me tan. So tan alpha will be equal to P cos 30 degrees minus 2 over 8 plus 5 sine 30 degrees. So my alpha is going to be the tan inverse of 5 cos 30 degrees minus 2 over 8 plus 5 sine 30 degrees. So when you press the calculator, let's see, alpha will give us 12.5 degrees. Very significant figures. So that is alpha. Now how can we get P? Now from here, since our alpha is 12.5 degrees, we can use one equation here, either this one or this one. Let me use the first one. So if P cos alpha is equal to 8 plus 5 sine 30 degrees, then my P is going to be 8 plus 5 sine 30 degrees divided by cos 12.5 degrees. So when you press the calculator, the P should give you 10.8 to very significant figures. So that is how we solve this number. Make sure P is the first. So make sure that you always dissolve along the plane and the perpendicular to the plane. So for the particle in equilibrium, it does not move. So that's how we do numbers of that type. We are still looking at equilibrium when there is no additional forces like friction, weight, and so on. But we can see where friction is taking part and even weight in the coming videos. So let us stop here.